These three equations are the most basic type of log equations. For all three of them, our method is we just want to switch the logs into exponential form and then solve from there. So for example, in this first one, we're in logarithmic form, switch it to exponential. Again, base of the log is the base of the exponent. Come around to the other side, so we have x cubed equals 8 over 27. And now from here, to get rid of a cube, we just take a cube root of both sides. When you take a root of a fraction, you just split it up to be the cube root of the top over the cube root of the bottom. So we get x equals 2 over 3. And that's it. Same idea for this problem. We just want to switch the forms around. So we have 4, bring it around to the other side, raised to the 5/2 power equals x. Now we can plug that into a calculator. However, just to do a quick review on these fraction exponents, 4 to the 5/2 is the same thing as saying the square root of 4 to the 5th, and doesn't matter what order you look at that, but since it's a perfect square, I want to do the square root first. We know the square root of 4 is 2, so now we have 2 to the 5th. 2 to the 5th is 32, so x equals 32. For this last one, same idea, switch our forms around. So we have 49 raised to the x power equals the cube root of 7. Now this one, we can't exactly take an x root. So here we just have to do a little bit of thinking. Excuse me. And we can rewrite this cube root of 7. That's the same thing as saying 7 to the 1/3 power. Now on the left side, 49 to the x, if we get these to be the same base, it's a lot easier to think about them. So I think 49 is the same thing as saying 7 squared. So we can rewrite that as 49 is 7 squared to the x power. Now whenever you raise an exponent to an exponent, you just multiply. So now this is the same as saying 7 to the 2x equals 7 to the 1/3. Well, if the bases are equal, then the exponents have to be equal. So we can bring this down to 2x equals 1/3, and therefore x equals 1/6. Both of these properties come from the fact that exponents and logs are inverses of each other, so they tend to undo each other. So the first property says if we have a number and we're raising it to an exponent, and in that exponent is a log of the same base, so something is raised to a log of the same base, well then all of that will cancel out and it just equals x. Vice versa, if we take a log of an exponent and the base of the log is the same as the base of the exponent, all of that cancels out and you're just left with x. So that's what those two properties say, essentially. Base of the log, base of the exponent cancel each other out. So in these examples, this first one, we have log base 7 of the 5th root is 7. Now whenever we're dealing with logs, you want to switch radicals into exponent form. They're a lot easier to deal with because the whole point of logs is to simplify exponents. So we can rewrite this as log base 7 of 7 to the 1/5 power. You'll always want to switch radicals into fraction exponents. Well, now using the property, if we have a log same base as the thing being raised to the exponent, those cancel out, the whole thing, and we're just left with x equals 1/5. For the second one, similar idea. We have 12 raised to log base 12. That means 12 and log base 12 cancel, and we're just left with x equals 5.